Okay. Let's finish this chapter with discussion on phase shift. So far, we have looked at the graph of functions. For instance, the sine, cosine, tan, and all of them. We've looked at the ones where there was no phase shift of the basic function. In general, suppose I have a sine wave, and this is a general form now of a sine wave that has potentially everything. It has amplitude, phase shift, period, and possibly a vertical shift. As the phase shift is, by the way, a horizontal shift. Okay, that's what it's called in the case of trig functions. The horizontal shift is called a phase shift. Okay, in this work, we assume B is positive, because if B is negative, for example, suppose I have sine negative 3x plus 1. If this, here's where B is negative, I can always factor a negative, right? And write this as x minus 1. And then this I can write as negative sine of 3x minus 1. In other words, because sine is an odd function, I can bring the negative outside. So for that reason, we know we can do that. Therefore, we think B is positive for the general discussion. Now, again, absolute value of A is your amplitude. D indicates the horizontal vertical shift. Now, our focus is on Bx minus C. And I'm thinking f of x minus h. Remember that work we did earlier where we talked about f coefficient in front of f of x, which is what this is. And we talked about f of x plus k, which is what the vertical shift is here. So I'm thinking about a horizontal shift, x minus h. And a combination with a of x here, because B acts as a in the general function. So here's what, in other words, I can do. I can write this as a sine factor B. We get x minus c over b, and then plus d. So I have a scale factor in front. It's called the amplitude here, but it's a scale factor. We have a vertical shift, and we have a positive constant, which causes a compression or a stretch in a horizontal direction, and the x minus h portion, this would be the vertical shift. I'm sorry, the horizontal shift of c over b, right? Because that's what the x minus h is. Your h is c over b. Okay, now b is positive. We agreed on that. So if you look at h here as a ratio of c to b, you can see that if c is also positive, then we have a horizontal shift to the right. If c is negative, we have a horizontal shift to the left. The magnitude of the phase shift is c over b. Okay. So let's actually now take a look at an example here. And I'm just going to look at 3 examples here with just sine, cosine, tangent. What we do also works with cotangent, secant, cosecant, but let's just focus on those. So let's say my function is 3 sine 2x minus pi. Okay, and you want to determine the phase shift, and we're going to graph this one. And don't worry about finding all these, all x-intercepts and everything that we found, domain, range, all that. Let's just graph these. One cycle is all we want. We know the amplitude of the sine is 3, right? Okay. Now this is how you start this. The period. You have a formula for the period. Again, I emphasize there is a formula, but we don't have to use the formula. The period is 2 pi over the coefficient on x, so pi is the period. But we can actually get this from our interval, the way I work it. Here's what I'm going to do. I'm going to look at the one cycle of the sine wave between 0 and 2 pi, the basic sine. Remember, this was the start, and this was the end. Oh, if you want, now we have a new creature called phase shift. Well, the phase shift, how do we find phase shift? We have a formula for that, don't we? C over B, phase shift, right? So in this case, the phase shift is going to be what? Pi over 2, because C is pi, right? That's C, and that's B. Phase shift is going to be pi over 2. And because C is positive, because we see this in this negative form, C is pi, greater than 0, so the phase shift is going to be to the right. Phase shift is right, pi over 2 units. But I don't need actually all this detail from the formulas. This interval will give me everything I need. Works like magic. Let's isolate x. To isolate x, I'm going to add pi to all three parts. So that's going to make it pi, 2x, and 3 pi. Then I'm going to divide everything by 2. So that's going to be pi over 2x. And this will be 3 pi over 2. The length of this interval from pi over 2 to 3 pi over 2 is pi, isn't it? And there's your period. We found the period earlier. We not only get the period from the interval, we also get right in here. There you go. This is your phase shift, pi over 2. And the fact that this number is positive, that means it is to the right. If that was negative pi over 2, that means your 0 is now at negative pi over 2. Remember, this is your start and that's your ending now. So what used to start at 0 and what used to is the sine wave. Sine wave, the basic sine, used to start or starts at 0. Now it starts at pi over 2. And here's how I'm going to graph this thing very easily and rather quickly. So I'm going to start at pi over 2. That's right in here, correct? And I'm just going to draw a sine wave right there. This is pi over 2. The ending is at 3 pi over 2. Those are 2 out of 5 points I need. Halfway between pi over 2, 3 pi over 2, it's 2 pi over 2, which is pi. Halfway between pi over 2 and pi, it's going to be pi over 4, isn't it? Therefore, you start at pi over 2. Add pi over 4 to it. That makes it 3 pi over 4. So here's 3 pi over 4. Each tick mark, therefore, is pi over 4. From 3 pi over 4 to pi, that's 4 pi over 4. Next one is 5 pi over 4. And 6 pi over 4, which gives you the 3 pi over 2. See how I can graph them? I actually graphed the function first, then I accommodated, I let the coordinate system accommodate the graph. Look at the amplitudes here. Remember, it's 3 because the coefficient on sine is 3. Therefore, the peak and the trough occur at negative 3. And there I have all the key points again. The trough occurs at 5 pi over 4 and negative 3. And another point on the graph is here, which is 3 pi over 4 and 3. Okay, perfect. See, again, to me, that's really the easiest way that I can graph these things. Quickly, easily, and accurately. More important than quickly is accurately. Let's take a look at another one. This time, I want to graph negative 2 cosine of 2x negative pi over 2. So how are we going to do this? Well, for cosine, I'm going to set it between, it is the argument of cosine, between 0 and 2 pi, and solve for x. So I'm going to add pi over 2 to all parts. 2 pi plus pi over 2 is 5 pi over 2. Correct? And then what? We're going to multiply every part by 1/2 or divide everything by 2. If you multiply by 1/2, half of pi over 2 is pi over 4. And half of 5 pi over 2 is 5 pi over 4. That's if I think in terms of multiplying by half. And there you go. Here's your phase shift, which is the start, by the way. Also, this is the start, and this is the end of the graph. The length of the interval, 5 pi over 4 minus pi over 4, is 4 pi over 4, or pi. This is the period. Isn't that cool? I get so much information from just one interval. Phase shift, starting, ending, period. They're all embedded in there. And let's do this. Let's graph it. This time I'm going to graph a cosine wave, right? And keep in mind, this is a -2 in front, right? -2 in front. So I got to remember to reflect the graph in the end. Okay, let's do this. Starting point is at pi over 4. Call this pi over 4. The ending is at 5 pi over 4. And they call this part 5 pi over 4. Okay. And I have one complete cosine wave in there. Start and end. Halfway through. And remember how the cosine went? The cosine wave goes, those are my 5 points. It's gonna look like this, right? That's my cosine wave. There's the cosine wave. And the negative will reflect it. True. So the low point is now actually the high point. And what's up here ends up down here. And there I have my graph. Isn't that cool? Now the tick marks. Each tick mark is pi over 4. So this is pi over 4. This point has coordinates pi over 4, and the amplitude is 2 and -2. Here the amplitude is 2. Okay, so that means the high mark is 2. The coordinates of this point, again, my tick marks are each pi over 4. So this is 2 pi, this would be 3 pi over 4. 3 pi over 4, the coordinates of the peak, 3 pi over 4 comma 2. Okay, got that one. What else? If you want the ending, we have the coordinates of this point. It's going to be, what that one is, 5 pi over 4 and -2. And there we have it. We label all the key points. The x-intercepts are at 2 pi over 4 and 4 pi over 4. Let me write that. My x-intercepts happen at pi over 2. That's 2 pi over 4. 3 and 4 pi over 4 is pi. Those are the x-intercepts. The x component of the x-intercept, that is. As a point, they're going to be pi over 2, 0, and pi comma 0 as a point. All right, and there you have it. The graph, the complete graph of that function, which includes a phase shift. Let's finish this chapter and this section with 2 tangent of 4x minus pi. Okay, let's take a look at this one. Now remember, for tangent, I set them up between starting and ending points of the asymptotes, right? 4x minus pi, and this is pi over 2. Add pi to all parts. So I get pi over 2 and then 4x, and this would be 3 pi over 2. That's adding pi to all parts. Then multiply everything by 1/4. So I get pi over 8x and 3 pi over 8. And here you go, phase shift to the right, pi over 8. The period is going to be what? 2 pi over 8 or pi over 4. This is the period of the function. And we got the phase shift. And what else did we want? That's it. The start and ending point. We know the start and ending point as well. let's graph this tangent function. The vertical asymptote starts at pi over 8. There you go. This is x equal pi over 8. And it's going to end at right here. And this one is going to be x equals 3 pi over 8. The whole graph occurs at pi over 4. The basic graph of tangent. And of course 2, remember that's just going to, if the basic tan looks like this, 2 times it's going to look like so. Right? So it's going to rise sharper than the basic one. That sort of bends around the 0, the x-intercept. And what else? So this is going to be, each tick mark is pi over 8. So this is 2 pi over 8. This is pi over 8, 2 pi over 8, 3 pi over 8 right in here. And 2 pi over 8 is pi over 4. The x-intercept for the one cycle is at pi over 4. And we got it. Notice how easy it was to graph these again. And with that, we are done with this lecture. This one rather short, because all we're doing is just graphing 3 things. And the way we're graphing them, we're not spending much time in graphing these, right? Because we're doing them the right way. So hopefully you do them this way. You can also read the book and see how the books do it. But this is how I do it, and it's worked. And I like the way it works for me. Hopefully for you as well. All right, everyone. Thank you for your patience, and thank you for watching the video. Until the next one. Take care.